So up until this point, we've been looking at lines, but only one equation of a line at a time. Today we're going to be moving on to systems of equations, which is where we're looking at multiple lines at a time. So first, what is a system of equation? An algebraic linear system is whenever you have two or more equations with the same variables that you are comparing. And again, since this is a linear system, that means That means we're talking about lines. So when we have two or more equations of lines with the same variables that you're comparing. A graphical linear system is whenever you have two or more lines, because it's still a linear system. Two or more lines graphed on the same coordinate plane that you're comparing. Okay, so systems of equations are ways that we can compare to either equations of lines or graphs of lines. And so what do we do with systems of equations? We solve them. We're going to be learning how to solve them in our upcoming lessons. Today we're just doing kind of a summary of what systems of equations are. And we're going to learn some graphical and algebraic ways to solve them. Okay, so when we're graphically solving systems of equations, the graphical solution to a system of equations is the point where the two lines intersect. So in this example, right where those two lines cross, that is our solution. It's also when one x value produces the same y value for both lines. So in this case, that solution, that point -2, 1, is a point on both of those lines. And so the important thing here that you remember is that a solution is a point, which means it has an x and a y value, so you need both. You can't just say x equals 2 and be done. You have to have the x and the y value, because the solution to a system of equations is a point. So algebraically, when we are algebraically solving a system, the solution to a algebraic system of equations is the point, again with an x and a y value, that makes both equations true. So that means that point has to work for both equations. It can't just work for one. Question? All right, so for this example, I'm just going to tell you that the solution to this system here is the point 2, 6. So to prove that this is indeed the solution, or why it is the solution, would be if we were to plug in 2 for x in both of the equations and 6 for y in both of the equations, we should get this answer. We should get a true statement for each one. So if we try that for our first one, plugging in 2 for x and 6 for y, it's 3 times 2 plus 2 times 6. We do that multiplication first to give us 6 plus 12, and 6 plus 12 is indeed 18, so this is true. that means it works for one, but in order for it to be a solution to this system, it has to work for both of them. So we have to check the other one as well. So if we plug in, again, 2 for x and 6 for y, we'll have okay, that's 4x, that's why I'm confused. Okay. Sorry. 4 times 2. Which will give us 8 minus 6, which is indeed 2. So since that's true, and that point makes both equations true, that is why the point 26 is the solution to the system, because it works for both equations. Yeah. I just told you the solution. We're going to worry about solving it later. I'm just showing you why it is the solution. Okay, so as we move forward with solving systems of equations, there are some skills that will be useful. One is being able to rearrange equations in different ways. So there are some different forms of equations that we have learned. So first is just being able to get a variable by itself, so being able to solve for either x or y. So in this situation, solving for x, we want to get x by itself. That means we need to move everything else to the other side of the equal sign. So when you're moving things to the other side of an equal sign, that's when you use the opposite operations in the reverse order. So this 3y term is being added, so we need to move that over. So we would subtract 3y from both sides. Can I combine the 17 and that 3? No, because the 17 does not have a y. They are not like terms. So you'd have to just leave it as negative x equals 17 minus 3y. You just leave them as two separate terms. And then x is almost by itself, but we have this negative out in front, which is essentially like a negative 1 being multiplied. Yes?
17 plus 3y.
Yes. How did you do that? Yeah. Yeah. You would divide, to get rid of this negative 1, it's being multiplied, so you would divide everything by a negative 1. Every single term gets divided. So you have to make sure that you do your addition or subtraction first, and then deal with your division. So you'd be left with x equals negative 17 plus 3y. X is by itself, so we're good. Okay. Or solving for y might be called for. So what would I have to do for this one to get y by itself? Yep, subtract 4x from both sides. The 4x are a package deal. That variable is attached to that number there. So if you're adding or subtracting, they have to move together. Can I combine the 12 and the 4x? No, because they are not like terms. So we're just left with y equals 12 minus 4x. And y is by itself. So we're good. Okay, so being able to solve for either x or y will come in handy as we move forward in these lessons. Another thing that will be helpful is being able to write equations in standard form. So if you remember what standard form is, that's where we have our x term plus our y term equals some number. So we have our x first plus our y equals a number. So we want x and y on the same side of the equal sign, and then our constant, or that number that doesn't have a variable, on the other. So it doesn't matter what side of the equal sign you move the variables to, you just need to pick one. So since we want our x term to be first, and this 7x is already kind of first on that side of the equal sign, I'm just going to move this 2y over, but you could move this 7x over as well if you want. It's just whatever you want to do. So how would I take this 2y and move it to the other side of the equal sign? Subtract 2y, yes. So then we'll have our 7x minus 2y equals a negative 3, which is our x term plus our y term equals a number. So you could also move the variables over to the other side. You could have subtracted 7x and then added 3 to get that. And that would be okay too. So, or you would end up with a negative 7x plus 2y equals 3. So if you notice, all of the signs are opposite. So either of these would be correct. It's just whatever way you want to move your variables. Okay, so I want you guys to take a couple minutes to do example 1 and 2. So example 1, you're going to solve for either x or y. It doesn't matter which one. You can pick whatever variable you think will be the easiest to get by itself. So example 1 is just solving for x or y. Example 2, we do want to write it in standard form. Okay, so example 1, solving for either x or y, you choose. Example 2 is writing in standard form. So the x term plus the y term equals a number. So go ahead, take a few minutes. I'll leave these up here so you can see examples. And we'll go over them in a few minutes. For these, with letter A, again, you could choose if you wanted to solve for y or x. It didn't matter. However, looking at our final answers here, was one easier to get by itself than the other? Which one was easier? Y. Y is easier because the only number in front of y is a negative 1. And 1s are easy to deal with because essentially it's just the variable. The issue came with x if you had to divide by a negative 5. That's where the fractions came in. So with letter B, in this case, if we look at our y value, the only thing preventing that y from being by itself is that it's being multiplied by a negative 5, and all of the other terms are nicely divisible by negative 5. So if you just divided everything by negative 5, you'd be good. Y would be by itself, and you'd have a nice equation, whereas you guys seem to have an irrational fear of fractions, which is funny because they're rational numbers. Get it? Remember that? Unit 1? Fun stuff. Okay. That was good. Thank you. I'm here all week. And then with C, again, x has no numbers out in front, so it's pretty easy to get by itself. All you have to do is add or subtract those other terms over to the other side. And then our last one, D, similar situation to letter B, where all the terms are divisible by 7, which is what's in front of x. Tyler, can you put that away right now, please? I don't care, please. Thank you. So if you just divided everything by 7, you'd be left with your x. Any questions on example 1? Okay. Example 2, writing the equations in standard form. Again, it doesn't matter what side you moved your variables to. So either one of these would be okay as long as you have your x term first, then your y term, and then it equals a number. So either of these would be okay. Or for letter B, either of these would be okay. Do you guys have any questions on example 2? Yeah. Okay, so moving on. Now we're going to start looking at word problems. Yay, word problems. It's okay. All we're doing today is practicing how to set them up. We're not going to be doing any solving today. So it's just writing the equations. So in this table, I have just some helpful keywords that can help you identify certain operations. So with addition, a popular one that you're going to see a lot is the word and. If you see the word and, that usually means things are being added together. An important or a common one with subtraction is less than or subtracted from. However, with these, it's a little backwards from what you would think. If a problem says that 3 less than x, it's tempting to just write 3 minus x, just to go in the order that it has those words in. However, that's incorrect. You can't do it like that. If it's 3 less than x, that means you have x amount of things, and then you take 3 away. So it'd be x minus 3. If you think about it in terms of money, if I'm saying, like, I have $3 less than you, and you have $20, how many dollars do I have? 17. How did you get that? 20 minus 3. You flipped it. So just keep that in mind. Subtraction can get a little tricky. With multiplication, times is a common one that you see, like 2 times as much or 3 times as much.
Will this be on our quiz?
Maybe. And then division, per is a common one. or percents are common as well. Shh, guys, please. And then equals when we're dealing with a total. If we're talking about is, are, was, were, any of these. Something is or was, that's when we know we're dealing with totals. So right now in example 3, we're just going to practice identifying what type of operations are happening, whether it be addition, subtraction, multiplication, or division. So letter A says 2 small pitchers and 1 large pitcher can hold 8 cups of water. Are we going to be adding, subtracting, multiplying, or dividing here? Adding, because of this word and. What about letter B? 1 large pitcher minus 1 small pitcher constitutes 2 cups of water. Subtraction because of minus. So what we're doing at this current moment, yes. Letter C, the test consists of true-false questions worth 3 points each and multiple choice questions worth 11 points each. Any ideas?
Addition.
Why? And, yeah. We're adding together the true, false, and the multiple choice. The food and medication for the dogs cost twice as much as those supplies for the cats. What are we doing here? Multiplication. What are we multiplying by? 2. Okay, so some helpful steps for setting up word problems. It's easier to do small steps, one at a time. Ian and Amelia. It's easier to do small steps, one at a time, instead of trying to do everything all at once, because I know word problems can be overwhelming. So if we chunk it up and just do one little chunk at a time, it'll be a little more manageable. So the first thing we want to do is identify the variables. So you're going to tell me what does x equal and what does y equal. We want to make sure we have units. And we can find out what the variables need to be by looking at the question. Our variables need to answer whatever question is being asked. So if the question is how many, your variable should be number of something. If your question is asking how much does something cost, your variable should be a dollar amount. Okay, so your variables have to answer whatever question is being asked. Then you want to determine your totals, what your equations are going to equal. So remember, this is where you can look for some of those keywords. Like the is, or was, or total, etc. Any of those words that imply a total is being used. Then you're going to determine what operations you will need to use, just like we did in the example above. So again, looking for those keywords. And then you want to just check to see, once you think you have your equation, you want to see if the units of your equations make sense. For example, you can't take number of people plus number of people equals $2,000. It doesn't make sense. You can't add people together and get money. But you can take money plus money equals money. So you want to make sure your units actually make sense in the equation. Okay, so let's do an example. So all we're going to do is set up the word problems. We're not solving anything yet. Our first one says one number is 5 less than a second number. Twice the second number is 11 less than 5 times the first. We want to find the two numbers. So the first thing we need to do is set or define our variable. So what are we trying to find in this word problem? We're trying to find the two numbers. So that means our variables can be x equals our first number and y equals the second number. Okay, again, your variables need to answer the question, what are the two numbers? These are the two numbers. Now we need to find our totals. So again, we're looking for words like is, was, total. Where do we see these words? Well, our first sentence says one number. What variable is representing our first number? X. Is, what does is mean? Equals. And then we have 5 less than a second number. So this is the less than thing, which remember is backwards from what you think. So what variable is representing our second number? Y. So it'd be y minus 5. There's your first equation. No, you were talking during it. Okay, then we look at our second sentence. Now we have twice the second number. What's that going to look like? 2 times y is, what does is mean? Equals. Then we have 11 less than 5 times the first. What would that look like? What about this 5 times the first? Let's start there. What does that look like? Yep. So 5 times what? X or y? What's our first number? X. So we'll have 5x, and then it's 11 less than that, so minus 11. Okay, and then those are our two equations, so those are set up. All right, let's do another example that actually has some units now. So letter B, 2 small pitchers and 1 large pitcher can hold 8 cups of water. 1 large pitcher minus 1 small pitcher constitutes 2 cups of water. How many cups of water can each pitcher hold? So to define our variables, we look at our question. How many cups of water can each pitcher hold? We have to define our variables. So x equals and y equals. So if the question is how many cups of water can each pitcher hold, our variables need to answer this pitcher can hold this many cups. The large pitcher can hold this many cups. So x can be
large pitcher and y is small.
Sure, it doesn't matter which variable you have be which thing. You just need to define it. You need to write it down. So x can be the number of cups in the small pitcher.
Here's a question for you.
Mm-hmm.
How many ounces can the large thing hold?
That's what we're trying to figure out cups right now. Number, and y can be the number of cups in a large pitcher.
Is it like gallons?
We're talking about cups right now, Amelia. Okay. Talking about cups.
Versions.
We're just worrying about setting up an equation right now. It doesn't matter. It does not matter if you have x be large or small or y be large or small. It does not matter as long as you label them. It doesn't matter. So now let's go through our sentences. So we have 2 small pitchers. What would that look like? 2x. And, what does and mean? Plus. And then we have 1 large pitcher. What does that mean? 1y, or you can just write y. Can hold 8 cups of water. What does that mean? Equals 8. There's your first equation. Okay, now let's look at our second one. 1 large pitcher. What does that look like? 1 large pitcher. Y. And then we have minus. What does that mean? Minus. And then we have 1 small pitcher. X. Constitutes is a fancy word for equals 2 cups of water. So equals 2. And that's our second equation. Okay, so we have to go word by word here in the word problem. Okay, let's take a look at letter C. A test has 20 questions worth a total of 100 points. The test consists of true-false questions worth 3 points each and multiple choice questions worth 11 points each. How many multiple choice questions are on the test? So this one is asking how many multiple choice questions. So our variables need to answer this how many question. So our x can be number of true-false questions, and our y can be the number of multiple choice. Or you can flip it. Again, if you want x to be multiple choice and y to be true-false, that's fine, as long as you set up your equations according to that. So now we need to find our totals. If we look at our first sentence, a test has 20 questions worth a total of 100 points. That is giving us both of our totals. Our first total is the total number of questions. So one of our equations is going to equal 20. And our second part here, a total of 100 points. That'll be the total of our second equation. So for the first one, to get the total number of questions, if we look at my variables, the variables are telling me it'll be the number of true, false, and the number of multiple choice. What can I do to those variables to get the total number of questions? Add them together. If I take the true, false questions, number of true, false, plus the number of multiple choice, that'll give me the total number of questions on the test. So it'll just be x plus y equals 20. But now when we're dealing with points, I can't just do x plus y equals 100 because I can't take number of questions plus number of questions equals points. That doesn't make any sense. I need to get my variables to be in terms of points somehow. So we use the second sentence here where it's telling us how many points each type of question is worth. So our true-false question is worth 3 points each. How many total points would my true-false section be worth, or how could I figure that out? 3x. And then my multiple choice questions are worth 11 points each. How could I figure out the total points for my multiple choice questions? 11y. So now I have my true-false points plus my multiple choice points equals my total points. Okay, so you just have to go little chunks by chunks. Don't try to do the whole thing at one time. That'll be too much. Okay. And then our last one down here, letter D. Margie is responsible for buying a week's supply of food and medication for the dogs and cats at a local shelter. The food and medication for the dogs cost twice as much as those supplies for the cats, and she needs to feed 164 cats and 24 dogs. Her budget is $4,240. How much can Maggie spend on each dog for food and medication? So our question is how much. So our variables need to be dollar amounts. So x can be the dollar amount per dog, and we'll have y be the dollar amount per cat. Again, you could switch it if you want y's to be dogs and x's to be cats. That's fine. Okay, now if we look at our second sentence here, it says the food and medication for the dogs. What variable is representing our dogs? X. Costs, that's an equal sign, that's a total. Twice as much as the supplies for the cats. What would that look like? Multiplication by what? 2. So we'd have x equals 2y. And now, in our last two sentences here, we have three numbers. We have 164, 24, and 4,240. Which of these is a total? Notice one of those numbers comes after the word is. Her budget is $4,240. Tyler, Mason. Stop talking. Okay. Since it comes after is, that means it's a total. So our second equation is going to equal $4,240. So that is a total amount of money. Our X and Y are just individual. This is for one dog and for one cat. How can we figure out how much total money we need to spend? Add them together, and what else? Because right now, if we just do one dog plus one cat, that's not going to equal $4,240. Yeah, but we have these other numbers. We know how many cats and how many dogs we have. So if we take the number of dogs, which is 24, times the cost per dog, that'll give us our total cost for all of our dogs. And for our cats, we have 164 cats times the cost per cat. I don't care. Will give us the total cost for all of the cats. So cost for all the dogs plus cost for all the cats will equal our cost for everybody.